That is, we called it the ACAS, like in the rugby, and the openings, that is to say, the technology we used, and the promise or the dismiss. On the 4 point, we will do a quite rapid synthesis, like in a takeaway. And the 5 point is for you. So, Pierre-Alexandre.
So how do we meet Hadoop? We have seen in 2014 two experiments, and the first one was very heavily advertised. It gave lots of ideas to many people. We have done a POC on a very large size credit card customer file, and we have done a mock-up in big data and machine learning with a very nice presentation and very nice intranet software built on Kibana and Elasticsearch. And what was nice is this mockup was made very fast, and it was very, very nice, very nice looking. And at the same time, behind the scene, another team was working.
Well, we were trying to reduce the bottleneck we had on a database to store profit and loss simulated for the value at risk. And we used a solution NoSQL, which is called a hash-base. You should know that.
And at this time, our retail colleagues have built for their mockup a POC on lab cluster with no security, but it was very convenient for us because it allowed us to start the first experiment. And our community started when we met some people from the global market and people from the IT the risk division. And we wanted, so we have created an initiative at this time, and we have decided to meet every Thursday to start working on big data, the technique and the practice. And the founding model were so global market, IT risk, and we have been able to onboard very fast our infrastructure friends.
So this one is for
I can do.
You can do.
In June, since we have done, after our first experiment, in June, we have decided to build our first real platform, that is the one with security, that was, it was built as being able to be copied in, as a security platform in the future. And we had two main goals. The first was to test if pilot projects were okay in real size, and also to see if two services of Natixis were able to share the same platform. Because in banks, it's not really the case. We have services which are normally very, very far away. And it was very important to see if it is possible to be together. And since we are today together, it was okay. And at this time, much of the regulatory project accelerate, and our boss asked us not to wait till summer 16, but to start the real project and the real infrastructure in January. Okay,
we decided to move forward because of the hot regulatory topics. For those who are familiar with regulatory topics in banking, there were two, and there is always, there were 2 points which were very important for us. The first point is, was the pilot project. Is called the regulatory initial margin. To make it short, it is the initial amount you have to have for your loan, and you apply it for trading. This computation needs a lot of sensitivity, that is to say, a huge amount of storage, and distributed storage was our idea for doing that. And the computation power was quite interesting as well to distribute it on a cluster, in a Hadoop cluster. The second point is not ended, as for the moment every bank are working on it, I think so, is the fundamental review of the trading book. This is the new vision for the market risk for the European Central Bank, and this new vision of the market risk is quite an heavy consumer of computation power and computation and storage and memory. So these 2 points make us the decision to move forward for Hadoop technologies. That's for you.
What have we discovered? We have discovered that with Hadoop we can be much more efficient because, as I have said before, in Hadoop what interests us is the technology but also the practice of the Hadoop world and of course the GAFA, all the internet company. And now, in a bank, we work a sequential way. That means 3 times a day, we compute a closing for Europe, Asia, and America. And at this time, 3 times a day, start long batches with sequential work. And of course, we have a big problem because we are waiting each other, and it's not very, very efficient. So with Hadoop and by working at the same place and being synchronized, we have been able to work in real time. We stop transferring data back and forth between us, the risk, the P&L, the finance. The data is copied at once, enriched and transformed in the same place, and it's much more faster. So we have written the free technology we have used for this project. HDFS to store the data in a secured place. We use Kafka now to synchronize the different silos together, and it's very, very efficient and very easy to connect. And we use a NoSQL edge-based for persistence. For long years, we have used what we call internally the big compute paradigm. That means we have now 35,000 cores. We each night compute the data, and Emmanuel will explain that, following the risk scenarios. And imagine the data that produce all these cores, and now they are connected almost automatically, directly to the big data. And a very important thing which has been created a few times ago, it's now we have a copy of all the golden source of Natixis, all the reference data are now present on the big data. That means when you are a developer, you can build very efficient code without having to connect to external database outside of the Hadoop cluster.
Okay, the next slide will really illustrate the data locality. This is a short slide to show you the current life cycle of the data we are exchanging between our four departments. So, as you can say, risks are sending risk scenario. They are generating risk scenarios that are giving them to the front office with this heavy big compute power, and they will produce risk indicators like sensitivities or P&L and distribute them to the P&L department or the finance department, and then for the risk, for producing the risk indicators. The account is for you. This one is what?
So remember our Thursday meeting. It is one of the most important things we have done since 2 years. We have started with the founding members, which are where a big part is there, and now we have onboarded most of the team in the bank ecosystem, in the bank global market ecosystem, the finance, the P&L, the risk, the compliance. And we work as a non-mandatory meeting. Everybody can come. We have also many contractors who come to give us ID. Hortonworks is present at each meeting so we can ask questions, we can hassle a little the project to see if they have chosen the right technology. We have people coming from the market feed who like to manipulate lots of feed at high speed. So we want to have a lot of diversity. We have the people from the marketing doing machine learning or high-level statistics. And what is very cool is that the infrastructure team is very present. They are very curious by this project, they like it a lot, and it's one of the projects they push and they help us a lot. And we try to have the same mood for everything. That means we go and see other industry to see their ID. For example, all the big internet company. And we also organize meetings. Us, the banker, we like that a lot. We organize meetings with all the banks or insurance company in Paris. And they come every time with two teams, the retail and the global markets. And so we can exchange and find good ideas and make this business continue.
And finish by a cocktail. Yeah. They like it a lot. We try to optimize as well the architecture. And that was an adventure, to boldly go where no man has gone before. I think you know the quote. And that was an unknown country where we went, and we are quite proud to succeed, to come back home. Our technical journey.
It is this spiral, we use it a lot internally to present our journey, because it avoids having the people fearing all the big name of the Hadoop animals and all the project who has been done. It can be seen, the start is really what we have had at the end of 2014. The stack, the choice of the stack, the HDFS, the ASBAS, and the Java. And during all these years, we have worked all these projects and all these different products. And now we are in 2017, we are on Hortonworks 253 in production.
So another ACA is the minimum viable solution. Try your own solution as early as possible and fail fast, as it was said yesterday by Société Générale as well. And proceed iteratively. It is important to iterate. If you fail, you are in a dead end, you change the way and you find another solution. It is important to work on the dev platform with real data, with the real size. That is to say that our development platform is as huge as the platform, the production platform. You can stress the platform, discover new issues, because there are issues. Find a minimum viable solution for each project. That means find a reference user, the guy that made the project, a starting kit, that is documentation, and publish everything on the enterprise social network, the bug and the issue as well. Another important point is you have to demonstrate the legitimacy of your solution to the sponsor. The sponsor is the business most of the time. So have an integrated AI solution is imperative. And Eczema is the shoes we have done. And then we have a machine learning enabled platform. That means we are doing machine learning and we are planning to do a lot more. What we have done, what we have achieved for now is more than 40 pilots and projects, and then in production. That's the opening, that is to say that the technology we use in order to manage the infrastructure and the security, we used the Ambari for provisioning and making the upgrade. That is quite useful. For the data encryption, we use Ranger KMS, and for the security, the authorization is Ranger. In order to monitor the performance of the platform, we use Ambarimetrics. For all the ETL and the data appenders, in order to input the data on the platform, we are using the HDFS DFS copy, is quite a standard, but as well the web HDFS, which is quite useful. For the ETL, we are using most of the time Hive with high latency because we are not using LLAP yet. For the low latency use case, and in order to manage the version control, we use a NoSQL container, which is HBase, and the command line Phoenix. I will let Cyril talk about more about the technology like Hive and Spark.
Thank you. So I'm here to present quickly the three main products that we've been using at Natixis risk department for the last couple of years, and to give you an overview of their complementarity. So let's start with Hive, because of course everybody starts with Hive. Some years ago, Facebook created Hive because they didn't want their data analysts to write Java programs by using the MapReduce API. At Natixis, we did the same thing. Of course, we didn't end up creating a new product like Hive, but yeah, we had to deliver very fast. So our choice, was to use a SQL query language provided by Hive. So Hive is a great tool if you want to see and explore the data. It's a great tool if you want to deliver fast, as I said. However, as a developer or project manager, it's not really satisfying because you end up creating or developing stored procedures that you can't test. I know it's possible, but it's kind of very complicated. You can't implement, more important, you can't develop iterative algorithms because you have to load and persist the data at every step, iteration, sorry. Okay, it's possible to inject or to distribute code through the use of user-defined functions, but again, the API of user-defined functions is not very cool, as Pierre-Alexandre would say. We decided to move to Spark 1 or 2 years ago. I don't remember. So sorry, I should have switched to this slide. I'm not here to compare Spark with Hive. It wouldn't be fair. Hive is not a computation engine, as Spark is. As a matter of fact, today it's possible to use Spark, as the computation engine of Hive. Even if I don't know any company using it, but it's possible. As I said before, we didn't use the MapReduce API or the Tez API because we thought it was too complicated and not really developer-friendly. With Spark, finally, we have an API that can be used by developers. It's a very sexy API because it looks like Java or Scala API for collection API, sorry. With Spark, you can test your code, you can develop iterative algorithm, which opens way to machine learning, as Pierre-Alexandre said. It also opens way to the processing, of streams of data. Of course, the switch from Hive to Spark was possible because the data stored in the Hive table was accessible through the Spark SQL module. Okay, Spark is great, but it's not a fairy tale either. It comes with drawbacks. And these drawbacks, I think everybody should be aware of before trying to go the same path as us. First, Spark is very memory greedy. It means that the same job you were running with Hive will take probably much more memory than with Hive. Second, Spark is evolving very fast. At Natixis, it wasn't clear at the beginning whether we should use the RDD or the data frame or the dataset API, especially the dataset which is not which is not really mature, at least with the 1.6 version of Spark. Sorry. And you have to make a choice between these three APIs, because switching from one API to the other during a job is quite expensive. Then there is maybe one last drawback, which is the Catalyst optimizer. Of course, it's a great tool because it optimizes the computation plan. It creates the DAG. But as a developer, you may find it, you may have difficulties, trouble to debug your program, because the Catalyst optimizer may change the order of transformation the developer or the data scientist has written in the code. So it's a great tool, but pay attention to the fact that what is executed is not really what you wrote. Voilà. The last tool. Sorry, j'ai le temps encore? Ouais. Ouais. Sorry, I forgot to display this slide again. The last tool we tried was HBase. We already spoke about this tool. Ouais. No. The use case for Spark was I need to expose my data, because Spark is great. You may expose data through Spark. We've tried that, it works. But it's not the main use case of Spark. So how do I expose my data to my clients? You can try with HBase, which seems to be the perfect fit for us, because the first time we just needed a distributed multi-map. Okay, it worked. But you should be aware that you don't have the same flexibility to structure your data with HBase than you would have with Hive, for example. And furthermore, HBase is not a cube. And that is to say a feature that is very important at Natixis. And I let Emmanuel speak about this subject.
Okay. Thank you. Well, I just talked about that a few slides before. The important point for the sponsor is to see the result of the big data. And we had to find a BI solution. And for most of the traders, the Excel spreadsheet is I will say the Swiss tool. It is used massively. So it is used massively. So we found a little startup which is called Indexima, and the performance were awesome. We can load 10 billion records in 10 milliseconds. So it is very interesting, and it produced through a Montagnon server a native XML cube, so that is quite easy to connect to this solution. The other technologies we use, as Pierre-Alexandre said just before, is the MOM Kafka, the middleware-oriented message Kafka. We use it in inter-application messaging to synchronize the data flows from one application to another, and to do streaming. The other tool we use in the stack is Scoop. It is very important for beginners to import the data from legacy databases. It works pretty well. And for the data science and prototyping, we use Zeppelin with Vaie, I think that's the pronunciation. Vaie, it is in the version on HDP 2.43. You have to use Vaie if you want impersonation. It doesn't work with the Zeppelin standard version. And finally, we have planned to use for the data governance Atlas and the dictionary Colibra. So let's make a synthesis of what we just said. Finally, it's really about association. Associate everybody in the project and bring them to discuss the point. The weekly meetings are important. It gives the pace for the projects, and it has to be quite dynamic and iterative. Share your projects with the community. That is to say, we build a community on the week during the Big Data Thursday, so we can exchange all the issue we had with the solution we found. When we find an issue, we have to find a solution. So this is the minimal viable solution I just talked about a few slides before. And the iteration process is the key as well, like in each agile process, I would say. The integrated BI solution, I just talked about that. And another key point is very important. We noticed that Kerberos is a key. You can find a lot of samples, which work perfectly well on the sandbox Hortonworks, on the Hortonworks sandbox. But as soon as Kerberos is involved, it doesn't work as easily that it should work. So you have to implement the development platform with Kerberos. It is a real important point. And for sure, in order to do that, you have to involve your providers. And thanks for Hortonworks to being involved in our project. They were part of the meeting. They still are part of the meeting we organize each Thursday. I think I'm done with the talk. If you have any question, there is no problem. We can answer them. Anyway, here are the context. We can discuss the point after the talk. Thank you. You have a question?
Just wanted to ask what was the biggest challenge for you during this project?
The biggest challenge. I think the biggest challenge is to convince as well, I think, to convince the sponsor and to convince as well the IT direction. It was quite difficult to, you know, the IT in the banking system is quite conservative because of the security. When you are dealing with your open source project, they are quite scared about that. And so you have to make it, I think you have to make a crash test. So we did it. So we try, and it crashed, and it's okay. So the business is okay with that. From nowhere, I don't know how long.
But what was nice is, since we organize as a community rather than silos, each developer team is giving example to the other one. Sometimes they are doing like a small race between each other to show the products, you know. So it's lots of emulation between the teams, and so we are able to find flagships and to show them to the business, to the boss, to everybody. The main important thing also is to start early because as the spiral show, there is lots of works in the journey.
There's another question over there.
What tool did you use for your machine learning?
Zeppelin.
For machine learning, we have installed on the server Anaconda and scikit-learn, and all the data scientists at work use this.
Your Spark ML
Voilà.
as well. Yeah.
So they use this, and of course they do lots of machine learning without the Hadoop environment. But for some very EV case, they have been able to project to zone analysis on the Hadoop. It's why Anaconda has been installed, and also now we are doing something like clustering the customer in real time or things like that in the global market and not on the retail, of course.
I think you were the third. I'm sorry.
Have you done any calculation on your return on investment over a year?
It's a big question we have now.
Well,
it's something we work also with Christian Billien from the Société Générale. What is very interesting on Hadoop is that it's very cheap. For example, in the bank, I will give you the lowest level example. A very large standard database like Oracle, Sybase, a big one with the history of the bank during the 10 last years, is something which is built to the business probably €1 million per year. If you transfer this history on the Hadoop, that will be built probably €100,000 per year or €50,000 per year. So they understand very well. That means the savings on the stupid project pay the rest. And of course, what was interesting is we couldn't have done the regulatory project because the standard centralized systems are completely at maximum
speed. It is
maximum
oversaturated.
speed for us. They are completely pushed at their maximum.
You got another question?
I just wanted to ask you about the infrastructure for your Hadoop system. So how many data nodes do you have? How much data you have? And if you have, I think you have an on-premise Hadoop infrastructure. So how you're basically managing your infrastructure? What is your security model?
Well,
probably we can. You will see our. We have our. We share lots of things with friends. No problem to exchange with. Now the production where there is 10 projects in production is a 12 data node system. And what we call the waves, because we have 40 projects on the development, and we encourage the developer to work in real size with no organization between them to create like a buzz on the server. We like the infrastructure team to see the problem on the dev platform and not on the production. And we have now pretty soon the development platform, which is organized as a production, will be bigger than the production.
I just want to precise that the 12 computers, the servers you were talking about, are kind of big. It's not small servers.
It's not workstation.
Yeah, it's really big. Okay.
This is grids, computer grid.
I know that in other banks
with
or other companies.
Strong capacity for the hard drive. Can I say the figures about Suzanne Oussancy? I think so.
Ouais, je voulais juste finir. Je voulais juste dire.
Finish.
I just wanted to say that in some other companies, they made a choice to use rather small servers instead of big servers like for Active Pivot or something like that.
We hear the Hadoop rules. It's not the bigger one you can find. It's a medium, big, normal Hadoop. It's a standard one, the middle choice.
Well, for the biggest table we have that contains the sensitivities, it contains, let's say, that 4 billion rows, I think. Am I right?
Now.
And we ingest, let's say, 77 million
100
rows
million per day.
100 million per day. That's not. Well, we can't say that it is the example for the big data, but it's beginning to be huge. And the issue is we have to keep this row online for a very a very long period of time because of fundamental review of trading book. So it will become bigger, very big.
For regulatory reasons, and also because some algorithms backtest are backtest on the past. So we
need to keep the past to predict the future. It's not exactly the good term, but another question? Yes, yes.
Like you said, the finance sector is a very regulated sector. I'm sure you guys have been doing some work on the new GDPR as well. How have you implemented or are you planning to implement the new GDPR regulation?
Well, that's a good question. In Natixis, we have two clusters. One for the corporate investment bank, where we put the data which are supposed to be not sensible.
Normal, sensible.
But they are strategic, but not sensible. And another cluster, which is for the retail, and it will implement the GDPR. So I'm not very aware about what they want to do for that, to be compliant with this new regulation. The point is this platform is quite compliant with a high level of security, and is to say it's in DMZ, and it is securized by cables, as it's obvious. And you have data encryption, data anonymization, and I think so.
Mostly, they use what we have discovered and make work in our project, and they install it in an island. You know, it is something very close, and
it's not easy to go on this cluster. Yeah. So I'm sorry, I can't understand. I can't answer your question. So I'm sorry. Yes. Yes.
For your production environment, do you use any backup structure?
A backup structure? Yeah, okay. So that's a really good question. The production environment is load balanced on two sides, and we have an archiving structure. It is another cluster, which is a kind of safe, and we do regularly backup from the production to this archiving structure.
The normal cluster is an active cluster located on two sites. It's not two clusters, it's one active cluster divided on two with two zookeepers in another place. And for security, our free cluster and the free cluster of the retail are backed up on what we call a safe. It's a Hadoop cluster which has lots of high-capacity disk and which is not that smart, and only some people of the infrastructure team have access to him to avoid any bad move. And there is a cycle of he receives a snapshot from the other cluster, of course from the production, but some of the development. And it is managed as a cycle over 1 month to be sure, and some parts are, of course, taped as normally.
We have planned to enhance the disaster recovery plan with a feature which was proposed by Apple to Hortonworks, which is called the block placement policy, and we are supposed to ask for a new development for Hortonworks on this feature. Other question?
No, we have to stop, I guess.
I guess it's finished?
Yeah.
Okay.
Thank you a lot.
Thank you very much.
Thank you.